Hey everyone, today we're going to be solving quadratic equations using a third method, that's with factoring. So hopefully you had a chance to practice review factoring because that skill is definitely going to be essential for today's lesson. I'm going to show you the PowerPoint slides that have the notes, and then we're going to go through the examples that are on the notes. Okay, so this is the third method to solve quadratic equations, and this is by factoring. So this method is useful when you have a quadratic equation that is in standard form and that it can be easily factored. So that kind of seems funny to have that part in your description, but I'll explain why as we go through the examples. You will come across quadratic equations that are in standard form that are not clearly factorable, easily factorable, and so there are other methods that you would use. But if you can see that it can be factored, this is definitely much easier than those other methods. So these are three basic equations in standard form. This one has all three terms, this one just has the two terms, and this one just has the squared term. If you had an equation that just had the square term, as we saw before, probably the best method for solving it would be to take square roots. But I put it here just so that you can see this does sometimes come up, and if it can be factored, you can solve using this method as well. The A, the B, and the C, and also the Y will be replaced with numbers, as you'll see in the examples. So we have these 7 examples. We're going to go through them all. You see all of these are in standard form, although the terms are kind of in different places. And these are of varying difficulty. We'll come back to these in just a minute and go through them one by one. So most methods of solving quadratic equations require you to set the equation equal to 0 and then find the zeros. This was true of the graphing method. If you remember, we had to get everything to one side, graph it, and look for the zeros or those x-intercepts, which are also called zeros. So this method is kind of similar. We're going to set the equation equal to 0, which just means get every term to one side so that you have 0 on the other side. And then we're going to factor the quadratic. And so hopefully you've gotten some good practice with that. The third step is to factor or to set each factor equal to 0, and I'll explain why that is true. And then solve each of those equations that you set equal to 0 to get your answers. All right, so let's go through some practice problems. I'm going to put on the document camera. Okay, so I really recommend that you take notes with me as we go through these examples and not just watch, because there's something that connects your hand and your brain when you're writing that helps you learn. So just watching isn't enough. You really need to participate and work through the examples with me. I'm going to set this up like we would in class with a note page. We are solving quadratic equations. I'm going to abbreviate that, quadratic equations, by factoring. Okay, don't forget that you can pause this at any time if I'm going too fast and if you need to catch up on anything. So let's go through these examples. Number 1 is x squared minus 11x plus 24 equals 0. The first step was to set the equation equal to 0. That's already done in this example. So the second step is to factor the quadratic. Here we have a quadratic trinomial, and the way we try to factor that is to set up the double parentheses. Okay, so we're going to factor that left-hand side. Since this has a coefficient of 1, probably the easiest method is the guess and check method. So let's try that. We want to factor this, and we're going to factor the x squared term as x and x. We're going to factor 24, and we have to think of two factors of 24 that are going to give us 11. Two numbers that multiply to give us 24, but are going to add to give us a negative 11 in this case. So the only way we're going to get a negative is if both of these are negative. So really we need to think of two numbers that multiply to give us 24, but add to give us 11. Can you think of what that would be? Okay, so I've thought of 8 and 3. It doesn't matter if you put 3 and 8 or 8 and 3. They just need to be like that. They need to be there. Okay, so if that is equal to that, then this is equal to 0 as well. So the next step says set each factor equal to 0. The reason we can do that is because you've got two numbers here. This is a number and this is another number. You're multiplying them together and you're getting 0. The only way for that to happen is if one of these is equal to 0. And that's called the zero product rule. Okay, it says if A times B equals 0, if A times B equals 0, then A has to equal 0 or B has to equal 0, or they could both be 0. But that's the zero product rule. And we can think about this if we just put some numbers in here for the A and the B. So if I have, what if I have 2 times B equals 0? Well, I know that B has to be 0. There's no other way to get 0. If these two numbers are multiplied together and I get 0, then that means B has to equal 0. Okay. If I had, let's say A times 6 equals 0, well, then I know that A has to equal 0. Okay, so one of those has to be 0. They could both be 0, but we just sort of say one or the other. Okay, so that's what we're going to do here. We're going to say that x minus 8 has to equal 0, or x minus 3 has to equal 0. Okay, and then we solve each one of these little equations to figure out what x has to be. You could probably do this in your head, figure out what number x has to be in each of these cases. Or if you're not sure, just solve these mini equations like we know how. I'm going to add 8 to both sides, so I get x equals 8. I'm going to add 3 to both sides over here, so I get x equals 3. And those are my two answers. Now, if you want to check this graphically, you would put this into your graphing calculator or into Desmos. If you want to verify that, you're going to get a quadratic equation. It's going to cross here at 3, and it's going to cross here at 8, and it's going to open up. So it's going to do something like this. You can check that on Desmos. So this is going to be your zeros, and those are the answers that you get there. So question 2, example 2, b squared plus 5b equals 0. This one's a little different. It doesn't have the 3 terms. And so we're not going to factor it like this, like we did up here. We're not going to factor it as 2 binomials. We can still factor it. And this is a good method to use to solve this equation because it's not that hard to factor. I can see that it has a common factor of b. So I'm going to factor that common factor out. And then in parentheses afterwards, I'm going to write down what would be the other factor. Remember how we did these? So if I factor out a b from b squared, that leaves me with b. And if I factor out the b from 5b, that leaves me with 5. Okay, I can check. I can multiply b times b, I get b squared, b times 5, I get 5b. So these are equivalent equations. I've got these two factors, they're equal to 0, so that means that either b equals 0 or b plus 5 equals 0. You can skip writing the word or, it's okay. This one's already solved. And that's one of the nice things about these simpler quadratic equations. If you've got just this simple equation, it's already solved for you. B is by itself. So here I'm going to subtract 5 from both sides and I get b equals -5. So that's the other answer. Okay, let's keep going. We'll do number 3. Okay, so this one is not set equal to 0 unlike the previous two. So I have to do that first. I want to get everything to one side. So I have to get this -4 over here. The way I'm going to do that is I'm going to add 4 to both sides. So I get x squared, and I'm going to put things in order, descending order, as we've learned. Squared term, then x term, then the constant term. All right, so at this point, we're going to factor. We're going to factor to this quadratic here. Set up your 2 parentheses, your double parentheses. And then we have to think of, well, I'm going to factor that x squared as x and x. I'm going to think of 2 numbers that multiply to give you 4, but add to give you 5. Can you think of that? You should have 4 and 1. And again, it doesn't matter what order you put those terms in, those 2 factors in. It could be x plus 1 times x plus 4. That's perfectly fine. You should check, always check just to make sure you've got the right factors. I didn't check up here, but definitely you want to check that your factors are correct. So 1x plus 4x gives me 5x. That's a good check. And then I'm going to set each one of these factors equal to 0 and solve. So this is going to give me x equals -4 when I subtract 4 from both sides, and this is going to give me x equals -1. Okay, let's keep going. Yeah, I'll go to the back side here. Actually, I'll start on a fresh side. This is example number 4. K squared equals 11k minus 28. Definitely not set equal to 0. So we're going to get everything to one side, and I would definitely like to keep my squared term positive if possible. It makes it a lot easier to factor. So I'm actually going to move both of these terms to the other side. So I'm going to do the opposite. That's a positive 11k. So I'm going to subtract 11k from both sides. That's a negative 28. So I'm going to add 28. And when I say both sides, I mean on both sides of the equals. So over here, this all goes to 0. And over here, I have k squared minus 11k plus 28 equals 0. Okay, so now we have to think of how we're going to factor this left-hand side. Pause it right now if you could, pause the video, and see if you can factor that left-hand side. I'll give you a few minutes to figure that out, a few seconds. Okay, so I get k and k. When you split up k squared, it's k and k. I know these have to both be minuses. It's the only way to get this to be a negative 11, but then multiplying gives me a positive number. So I have to think of 2 numbers that multiply to give me a positive 28, but add to give me a negative 11. So both of these have to be negative. Can you think of 2 numbers that multiply to give you 28, but add to give you 11? So I think it's 4 and 7. Okay, let's check. This is negative 7k, this is negative 4k, and yep, that adds to negative 11. So that checks. So now I'm going to say k minus 4 equals 0, k minus 7 equals 0. This is going to give me k equals 4. This is going to give me k equals 7. And those are my 2 answers. It's not too bad a method. If it's easily factorable, once you have it set equal to 0, it's pretty quick. Let's try example number 5. Okay, so this one's going to be a little bit harder because it's got a coefficient in front of the square term that's not 1. It is set equal to 0, so that's good. But in order to factor this, we need to figure out what 2 factors are going to make this equal to 0. And this is where that x method comes in handy. So over here, I'm going to set up the x method. Remember, we're going to multiply these 2 together. 3 times negative 49. 3 times 49 is 147. So it's negative 147. But I also know that's 3 times 49, right? I'm just going to write that there. And then the plus number is 14. So I have to think of 2 numbers that multiply to give me a negative 147, but add to give me 14. Okay, so let me break this apart. I know negative 147 is 3 times 49. And I know 49 is 7 times 7. If one of these is, if this is a negative, then I also know one of these is negative and one of these is positive. So I have to think of a way to combine these prime factors here so that I get, when I subtract, because these one's negative, one's positive, when I subtract the numbers, I'm going to get a positive 14. Well, I know that 49 and 3, negative 49 and 3 is not going to work because that's not 14. But if I put 3 and 7 together, that's 21, and then that leaves me with a factor of 7. If the 21 is positive and the 7 is negative, that's going to give me 14. So I want the 21 to be positive and the 7 to be negative. All right, then remember what we do is we rewrite this, we bring this down here and we rewrite it 3x squared minus 7x plus 21x minus 49, and then we factor by grouping. The only common factors here are x. So I have x, I factor that out, 3x minus 7. The common factor here, it looks like it's going to be a positive 7. That gives me 3x minus 7. Right? So when we see those common binomials, we're going to write that down, 3x minus 7 and x plus 7. Those are my two factors. So I'm going to bring those over here, 3x minus 7 and x plus 7. Let's just double check. So that gives me a 21x, and that's a minus 7x, and so that does check to be 14. So I set each one of these equal to 0 and solve. Now this is a little bit harder to solve because it's 2 steps. I have to undo the 7 and I also have to undo the 3. So I am going to write this out step by step. 3x equals 7 divided by 3, x equals 7/3. And then this one I subtract 7 and I get x equals negative 7. So those are my two answers. Okay, that one was kind of tricky, huh? Big jump forward in difficulty from the first 4 to question number 5. Let's take a look at number 6. This is another kind of problem similar to number 5. So I have this. First of all, it's not set equal to 0, so I want to do that. I'm going to subtract 43x and I'm going to subtract 30 from both sides. So I get 8x squared minus 43x minus 30 equals 0. I just subtracted 43x from both sides, and then I subtracted 30 from both sides in my head, and I wrote it all out. Okay, let's see if we can factor this. Set this up. Again, I want to use the x method. I want to multiply 8 times 30, and that's a negative 30, so it's going to give me a negative 240. And then it has to be adding to negative 43. Again, this is going to tell me if that's a negative, then one of these is negative and one of these is positive. Let's see if I can figure out what that's going to be. 240 is, I know, 3 or 30 times 8. 30 is 5 times 6. 8 is 4 times 2. 6 is 2 times 3. 4 is 2 times 2. So I've just written my little factor tree here. I've got all these little dangly leaves at the bottom that are the prime factors. I want to try and figure out how to put them together so that I end up with 2 factors that multiply to give us a negative 240 and add to give us a negative 43. Let's think about this. So if I put 3 times 2 together, that's 6 times 12. Times 2 is 12. Times 2 is 12. Times 2 is 40. 2 times 12, 24. Nope, that's not going to work. I got to think about this. I've got 15 times 8. That won't work. Keep thinking, keep thinking. So 30. Oh, there's another 2 over here. I didn't see that one. So if I did 24 times 10, no, that won't work. 48, 5, that'll work. Okay, so if I put these three together, all of these together, 2 times 3 times 2 times 2 times 2, that is 48. And then the remaining factor is 5. And I know if I subtract those, if this is negative and that's positive, then I get a negative 43, which is what I want. So I want my 48 to be negative. I want my 5 to be positive. And then I'm going to rewrite this. I'm going to bring this down here. Actually, this one here. I'm going to write 8x squared. In place of negative 43, I'm going to write negative 48x plus 5x minus 30. And then I'm going to factor by grouping. I know 8x is common to both of these, so I get x minus 6. And I know 5 is common to both of these, too, so I get x minus 6. And I get x minus 6 here. I'm bringing out those two binomials that are common there. And that leaves me with 8x plus 5. So those are my two factors, x minus 6 and 8x minus 5. Set each one of those equal to 0. This one's just going to be x equals 6. This one I have to subtract 5, or add 5, excuse me, add 5. 8x equals 5, divide by 8, so I get x equals 5/8. Those are my two answers. Okay, we have one more. Take a look at this last example. This is example number 7. It's 2k squared minus 14k equals negative 3k. So I want you to pause the video at this point and see if you can work out how to solve this equation by factoring. Think about what we've done so far, what the steps are, and see if you can get how far along you can get. Go ahead and pause the video. Okay, so coming back, you should remember that the first step is to get the equation equal to 0. So I want to get this term to the other side. So I'm going to add 3k to both sides. So I get, I wonder if I've written this down wrong because I'm surprised there's a k there. Anyways, so we're going to write it. We're going to go ahead and go with the flow here and work this out. So there's no trinomial here. It's just the two terms. So I'm going to factor out a k, which is the only thing that's common to both of these. All right, those are my two factors that are set equal to 0. So then I set each factor equal to 0. This one's already done. There's nothing else for me to do to get the k by itself. This one I have to add 11 to both sides and then divide by 2. So I get, dividing by 2, I get k equals 11 halves, or 5.5. Okay, so those are our examples. You're going to have some problems to do where you have to follow these steps. Okay, if you have any questions, please let me know, and we will have a video session where we go over the answers next week.